Good day. I am Mark Russell HBS, and today we're gonna discuss this research entitled "A Reconnaissance Survey for Proposed Road Construction Project Using Gravity Method of Geophysical Investigation in Magban Aladi area of Ibejuleki, southwest of Nigeria" by Ishola SA 2024. Road infrastructure is a fundamental component of socio-economic development, facilitating transportation, trade, and access to essential services. In Nigeria, the rapid expansion of road network has been accompanied by significant challenges, particularly premature road failures. These failures manifest as potholes, cracks, and deformation, often resulting from poor construction planning or practices, substandard materials, and adverse geological condition beneath the roadbeds. The area of the study of this research, the Magbon Alade area in Ebejuleki, located in the southwest region of Nigeria, is one of the notable areas that have been identified as a feeder road linking the popular Lekki Aja Epe Express Road, making it a potential site for a proposed road construction project in the zone. The road after construction should serve as an access route to Dangote Refinery at Epe. The congested states of the aforementioned express road have over time slowed down the pace of vehicular motion, which in turn has negatively affected the socio-economic status and development and commercial activities in and around the area of the suburbs of the entire Ibejuleki. For the engineering application of the gravity method, the study is under discussion employs the gravity method of geophysical investigation to conduct a reconnaissance survey of the Magbon Alade area. The gravity method is a non-invasive technique that measures variations in the Earth's gravitational field caused by differences in subsurface density. By identifying these areas of low and high density, the survey aims to detect geological structures that may influence the stability of the proposed road construction. This approach provides essential data to guide engineers and planners in designing a road that minimizes the risk of premature failure. The methodology. The reconnaissance survey was conducted using a CD5 autograph gravitimeter, a precise instrument capable of detecting minute variations in gravitational acceleration. The study area, situated within the Dahomey Basin, features gently undul- undulating terrain with elevations ranging from 50 to 200 meters above sea level. The survey was carried out along a 5 traverses with stations spaced every 5 meters to ensure detailed spatial coverage. At each station, we have 4 cycles of gravity readings, which is denoted as N1 for cycle 1, N2 for cycle 2, and so on. These were taken to enhance the accuracy and reliability of the data. A base station is also established, and readings were taken hourly to correct for temporal variations in the gravitational field. For the data collection, as I said earlier, readings are taken at base station every 5-meter intervals along the traverse lines. We also have the 4 cycles conducted, each lasting for 4 minutes to ensure the data reliability. The raw data underwent processing to calculate the Bouguer and residual gravity anomalies, which were then plotted to visualize the spatial distribution of subsurface density variation of the data. This data processing includes the data is inputted into a Microsoft Excel for processing, and Bouguer and residual anomaly plots are generated to identify the gravity anomalies. The gravity method is particularly suitable for this type of investigation because it can detect density contrast caused by geological features such as faults, fractures, cavities, and variations in rock type. These features are critical in assessing the load-bearing capacity of the ground and in identifying zones that may require geotechnical reinforcement. Now for the results from the gathered data, the gravity survey revealed significant variations in gravitational readings across the study area. The maximum and minimum readings from the four cycles at various stations indicated a wide range of density contrast. For instance, we have in the first cycle recorded a maximum gravity value of 35,830 milligal at base station 5 and a minimum of 27,594.8 milligal at base station 1. Similarly, the fourth cycle N4 also show a maximum of 37,444.3 milligal at base station 7 and a minimum of 3,246.4 milligal at base station 4. Here are the gathered gravity anomalies from N1 to N4. Next is the residual anomalies. Residual gravity anomaly plots along traverses exhibited both positive and negative anomalies, ranging approximately from negative 5,000 milligal to positive 2,700 milligal. So what does this indicate? Well, negative anomalies typically correspond to zones of lower density, which may indicate the presence of weak or unconsolidated materials, meaning it can have cavities or fractured rocks. Conversely, positive anomalies suggest a higher density materials such as a competent bedrock, which are more suitable for supporting a road infrastructure. The spatial distribution of these anomalies varied laterally along the traverses, highlighting the heterogeneity in the subsurface geology. This heterogeneity underscores the necessity of the site-specific geotechnical consideration in the road design process. The discussion and findings, we have the gravity survey's findings have important implications for the proposed road construction project here in Alade area. The identification of low-density zones suggests areas where subsurface materials may lack sufficient strength or cohesion, potentially leading to a differential settlement or, in which case, road failure if it is left unaddressed. On the other hand, we have zones characterized by high density anomalies are likely to provide a stable foundation for the road construction project. Neither. Recognizing these areas allows engineer to optimize the alignment and design of the road, minimizing construction costs and enhancing longevity. In conclusion, the reconnaissance gravity survey conducted in Magbon Alade area of Ibejuleki here in southwest Nigeria has successfully delineated subsurface density variations relevant to the proposed road construction project. The results revealed a heterogeneous subsurface environment with distinct zones of low and high density. This provides valuable findings and insights of the geological conditions of the rock layers for the road's performance if it undergoes a road construction project. Incorporating this survey for the road design will enable the engineers to identify and mitigate potential geotechnical hazards on the ongoing project. thereby reducing the likelihood of premature road failure. This study exemplifies the importance of these geophysical methods, such as the gravity survey, which is used in this research. In it is important in infrastructure planning to ensure sustainable and resilient development.